Thank you, everyone. Well, thank you for coming along to my talk this morning. So, I'm going to be talking to you about my current Masters by Research project, which is titled Investigating Deccan-Induced Environmental Changes Prior to the Cretaceous-Paleogene Mass Extinction. And this is a project I'm doing in collaboration with my primary supervisor, Professor Dick Freeman, who many of you may know in the department, and my co-supervisor, Dr. James Barnett, who is a postdoc here at St Andrews. So I just want to set the scene and take you back 66 million years ago to the end of the Cretaceous period. This was a very dramatic time in the geological past. We had two catastrophic events going on in a relatively short pace of time. We had the Chicxulub impact, which is what you can see here, striking the Yucatan Peninsula in Mexico. It was a 10-kilometer wide asteroid and created a crater up to about 100 kilometers across. At the same time, though, we also had in where present-day India is today large eruptions and an emplacement of a large igneous province, the Deccan Traps. And ever since the advent of the Alvarez hypothesis, the idea that we were struck by this large impact, there's been a to and fro very controversial debates, primarily in the last decade as well, over which of these two were the main trigger of the Cretaceous-Paleogene mass extinction. So, although currently a lot of the research is focused on the Chicxulub impact and its effects after the extinction event, there has been not as much work done on the environmental impacts of the preceding Deccan volcanism. So what do we know about the environmental impacts of Deccan volcanism already? So many of you might have realized already that in this small photograph here, there's people. This is not actually a picture of the Deccan Traps. This is a picture of the recent Icelandic eruption, which was captivating a lot of volcanologists in Iceland recently on the news. But just to give you a scale here, the emplacement of that lava flow compared to Deccan would be at its fullest extent about 108 million times larger. So that can give you some kind of grasp at the size of Deccan. At the fullest extent, Deccan was about the size of France. It was a huge emplacement of lava. So obviously that must have done something to the environment at the time, just before the end Cretaceous mass extinction. And the best records of this come from the Ocean Discovery Programme records 1262, which are located here in the South Atlantic. You can see these beautiful drill cores here. You can clearly see the position of the end Cretaceous mass extinction here. This transition from this forearm ooze, pale forearm ooze, transitioning into very dark muds. But what you might also recognise is, like some researchers have already, that there are areas within the core before the event which show increasing iron intensity, which might be a proxy for increasing ocean acidification. But this is something that should be tested further. So at the same time, around 66 million years ago, we also have in the climate records an extreme warming event, which is known as the Late Maastrichtian warming event. And there's been some debate within the scientific community over if this warming event was actually driven by Deccan outgassing. So what we have here is from the same record, 1262, a benthic oxygen isotope record, which is a proxy for temperature. And all you're really seeing here is that just after the chrome 30N, chrome 29R boundary, we're seeing this huge negative excursion, which correlates to an abrupt warming event. And this is what we classify as the late Maastrichtian warming event. And some recent work by Barnett and others in 2017 has actually produced some very high resolution records for this event. But what we're seeing here in this graph is that it doesn't seem that this warming event coincides with changes in the Earth's eccentricity. So when the warming event initiated, it was during an eccentricity minimum. So the Earth was far away from the Sun at that time. So it doesn't seem to be an orbitally induced event. Also, we've seen a very unusual muted carbon isotope excursion here. So it suggests perhaps a source of heavier mantle carbon, but this is still up for debate. So going forward, the main aim of my Masters by Research project is to quantify the changes in climate and carbonate chemistry related to ocean acidification that occurred during this latest Maastrichtian time. And that's the same interval from Barnett 2018. And we're seeing that the period up until the impact, it was a dramatic time. We're seeing that the climate was cool for a majority of the end of the Cretaceous, the late Cretaceous, but just before the impact, we're seeing this abrupt warming recorded in the oxygen isotopes, followed by this cooling, stepwise cooling of 4 degrees, and this is a substantial warming of about 4 degrees. So the primary objective of my project will be to determine if ocean acidification did occur during the late Maastrichtian warming event, and I'll be using, I'll go on to that in a minute, and be using boron and calcium for that. But I also have secondary and tertiary objectives looking at calculating the magnitude of temperature change, which will be using magnesium-calcium proxy, trace element proxies, and then also a tertiary objective looking at generating some planktic oxygen and carbon records, as these records, existing records, are from the benthic or deep sea. So to go on to focus into objective 1 a wee bit more, so the methodology behind that is that boron calcium trace element and boron isotope proxies, which I will be using for addressing objective 1, have been used before to indicate oceanic pH. And the way this happens really is that we can imagine a scenario in which we have the Deccan Traps erupting here and outgassing lots of CO2. CO2 enters the atmosphere and then is absorbed by the ocean. And as most of us know, CO2 is this weak acid and causes ocean acidification. It's a problem that we're facing today with current climate change, and it also happened in the geological past as well. So this absorption of CO2 causes a fall in pH and a fall in borate ions. So this drop in borate ions translates to changes in the trace element ratios within calcifying organisms like this benthic foram here, Nuttallidis trumpii, which will be my target species for this study. And the drop in borate ions relates to a decrease in the boron to calcium ratio that were recorded within the calcite tests of these forams. Also, when all this is happening, we have a change in the chemical gradient of the ocean. The lysocline gets shallower, and this relates to a drop in calcium carbonate within the core and an increase in iron intensity. So this has led me to make my first hypothesis, which would be that a new boron calcium trace element data should record ocean acidification during this late Maastrichtian warming event. So now we're on to sample preparation. So how do we get to generate these records? So we start with the material picked from the core. That's me there with a binocular microscope. And I look through the core material and identify the species, the Nuttallidis trumpii. I then pick those species and group them together. That's here. And then just recently, just yesterday, I've taken my samples over to the University of St Andrews to use their laboratory here to run trace element analysis. So that's me there. And now we're just placing the samples within the triple quad ICP-MS mass spectrometer at St Andrews, and this machine will be used to generate the new boron calcium data. So I haven't generated the data yet, but I can give you what I anticipate the data might look like. So what we have here, is the oxygen isotope data for the late Maastrichtian warming event, this warming. And then we have here also the percentage of calcium carbonate within the core. And you can see that during the event, the calcium carbonate percentage fluctuated quite a lot within the main interval and then recovered after the event. So I anticipate that the new boron calcium data, which is here, this is just a prediction of what the graph may look like, should correlate nicely against perhaps the calcium carbonate percentage. So when we see increases in calcium carbonate in the core, we should see increases in boron calcium ratio, and likewise decreases in calcium carbonate. should relate to decreases in the boron-calcium ratio. And why is all this important? So today we are, as I mentioned, we are experiencing anthropogenic climate change, but if we look back, this is a lovely record produced by Westerhold et al. Dickren was involved in this study as well. And what we see here is a pretty much a really good temperature record over the last 66 million years, which recently was published last year. And what we're seeing is that under some climate scenarios, humanity has the potential, if it so wants to potentially raise global temperature as much as 12 degrees by the year 2300, which would be comparable to the warming seen during the Lake Maastrichtian warming event. So what this pretty much concludes is that by studying past events like this, it can better inform society and the wider scientific community about the longer term environmental consequences of our current climate crisis if we allow society to continue to burn fossil fuels. However, this is not locked in. We have time to determine our own climate future. So let's hope we do not see the environmental consequences of the Lake Maastrichtian warming event in our future. And that's me. Thank you very much, and I'm happy to take any questions.
Great. Thank you, Matthew. Let's unmute and give some applause to Matthew. I forgot to give you your 8-minute warning. Do you have any questions? Please just raise your hand or stick something in the chat. Gus.
Hi, yeah. Thanks. Really interesting talk and really nicely presented. I just wondered if, I'm not involved in this field, so apologies if this is a silly question or a rude question.
No worries. No.
But all of the data comes from the one ODP. Does it like 1262, whichever one it was?
Yeah.
I just wondered if there were more data points from other parts of the world that showed the same thing, and whether, I mean, obviously in a master's, you might not have the time to do, but whether that would be something to consider for future work, would be to compare to other well records.
Yeah, definitely. So the records I showed towards the start, that was my co-supervisor James Barnett. He done his PhD looking at the long-term records and generated that first oxygen isotope curve. So yeah, it's definitely something that the methods we're using here could be applied to other cores. So we do see the oxygen isotope excursion in other places around the world, but no one's ever generated the trace elements, the boron calcium proxies for the event before. So that would be quite useful. But yeah, potentially you could go to other localities and do that and hope to see the same sort of outcome. But yeah, it seems to be that from the material that we have so far from other sites as well, they're all recording this kind of anomalous warming just before the impact. So, but what that warming did, how bad, what was the consequences, was still an open question. So, yeah.
Cool. Sounds like a good opportunity.
Yeah, definitely. We'll see what the results say.
Great, thanks. Are there any other quick questions from anyone? Screen's gone
I've got a question.
Sorry, who is that?
Hi, Ian.
Okay, just go ahead.
So are these boron calcium isotopic ratios, do they come out successfully in other acidification events through time as effective proxies of acidification?
Yes. So the boron calcium trace element technique's been used before. Late after this event, it's been applied to the Paleocene. That's the kind of the warmest interval in the last 60 million years, and we're seeing quite good results. These are relatively new proxies, but they have been used before, and they have been used, and by some authors have been using these to suggest significant changes to the pH and the acidity of the oceans at those times. So yeah, it's been used before, and it seems to be a rising star within the proxy proxy techniques to be used on such events. Yeah.
Okay, thanks.
Great, thank you, Matthew. So I think in the interest of time, just to be fair to all the next presenters, we better call a halt there to this session. Thank you very much. Thanks to all the speakers. The next session is in fact a poster session, which is for the next half hour. So I encourage you all to go and see the posters and do provide feedback to the poster presenters or send them questions and so on. And before you do, if you could just check the chat here, I've put the links to give feedback to all of our speakers in this session from the last 6 talks. If you haven't done so, please do give some feedback to the speakers because they will really appreciate it. And that's the purpose of this, or part of the purpose of this conference. So thank you all very much indeed, and see you in the next sessions after lunch, after the posters.